Hi, on this lesson, I will discuss about access control list or ACLs. ACLs are widely used in computer networking and in network security for mitigating network attacks and controlling network traffic. Standard ACLs filter traffic packets based on the source address only. Extended ACLs filter IP packets based on layer 3 and layer 4 source and destination information. Instead of using a number, a name can be used to configure an ACL. After creating an ACL, the administrator can apply it on a router's interface or line with a specified direction, inbound or outbound. To configure number and name ACL, we use a command. To configure standard number ACL, we use access list and enter the number and then permit or deny or remark and enter the source address. To configure extended number ACL, we use the command access list and enter the number and then the action permit, deny or remark and then the protocol, for example TCP, UDP or IP, the source address, the destination address and the port number and the keyword establish. Establish means indicates an established connection for TCP only. To configure a name ACL, firstly we name the ACL by using the command IP access list and choose standard or extended and enter the name of the ACL. And then we configure ACs or rules. If it's a standard ACL, we enter the command permit or deny or remark and enter the source address. If it's a extended ACL, we enter the command permit, deny or remark and enter the parameter similar to the number ACL. Now I open the package JSON file configuring extended ACL scenario 1. There is a topology. Two employees need access to services provided by the server. PC1 needs only FTP access, while PC2 needs only web access. Both computers are able to ping the server, but not each other. Part 1. Configure, apply, and verify an extended number ACL. Step 1. Configure an ACL to permit FTP and ICMP. We create an access list because the access list number we want to create is an extended, so we enter 100. We want to permit FTP, so we enter the keyword permit. Because FTP use TCP, so we enter TCP on the protocol. About the source address, because we want to filter any devices on this network, so we enter the network address. About the wildcard mask, because this network is slash 27, so the wildcard mask is 000.31. About the destination address, because we have filter services on the server only, so we enter the keyword host and the IP address of the server. About the port number, we enter the keyword equal, as you can see, FTP service with the port number 21, but we can use FTP keyword, and then we press enter. So this extended access list will permit or allow TCP from this network to the server with the port number of FTP. Now we create another rule to allow ICMP from the PC1 or from the network or from this network to the server. And now we show the access list by using the command do show access list. As you can see, we have a standard IP access list number 100, and the first rule is to permit TCP from this network to the server with the FTP protocol, and the second rule is to permit ICMP from this network to the server. And now we apply this access list on the router interface, and you can see on the router one we should apply this extended access list as near as the source network, so it will be the gigabit Ethernet 0/0 and with the inbound direction. So I enter the interface mode. We can verify our configuration by using the command do show run. And you can see on the interface gigabit Ethernet 0/0, we have applied an access list 100 inbound direction, and there is the access list. Now we verify our configuration on PC1. We FTP to the server. with the username of Cisco and the password is Cisco. As you can see, we are successful logged in to the server using FTP. Now I quit from the server, and from PC1 I ping to the PC2. I get the IP address of the PC2. As you can see, PC1 cannot ping to PC2 because the ACL list block all other traffic.